Last session, we have seen about the cloud formation and how we can create an infrastructure with the help of cloud formation, which is IaaC, infrastructure as a code. So we are going to create an infrastructure with the help of the code. We are going to create an infrastructure with the help of the code, and we have created the infrastructure as well, and it is called as stack. Cloud formation, it is also called as stack. So, and we have seen how to create an EC2 automatically, how to configure the S3 automatically with the two types, one with a direct template, and we have also designed our own template as well. We have also designed our own template. So maybe in AWS, we have two more topics. One is elastic load balancer, and other one is automatic auto scaling group. We have one is elastic load balancer. The final topic is auto scaling group. Again, after completing the DevOps, we will be coming back to AWS for completing one more service, which is Beanstalk, which is Beanstalk. As of now, we'll be completing elastic load balancer plus the auto scaling group as well. So first, today we will see what is this ELB. What is this ELB? ELB is nothing but it is the elastic load balance. ELB is nothing but it is the elastic load balancer. Elastic load balancer. What is mean by load? The incoming traffic. What is mean by load? The incoming traffic. Incoming traffic for my application. For my application, that is called as load. Then balancing means. We are going to balance the load. We are going to balance the load. We are going to balance the load. That is called load balancer. Balance the load. So incoming traffic. I'm going to balance the incoming traffic. I'm going to balance the incoming traffic. So there might be a more incoming traffic. There might be a more unexpected incoming traffic. Anyway, I need to manage those. I need to balance those incoming traffics. I need to properly allocate to the server. I need to properly allocate to the server whichever is free. So that is load balancing. Elastic is something you can drag it as you wish. So elastic may be scale out and scale in. So if what is this elastic, right? So we have an elastic band. So whenever you drag it, it will drag till some extent. Whenever you leave that band, it will again shrink it. So you can extend based upon your convenience. You can extend this based upon your convenience. That is elastic. So elastic. So based upon your convenience, you can balance the incoming traffic. Based upon your convenience, we can balance the incoming traffic. That is elastic load balancer. That is elastic load balancer. Okay. In this elastic load balancer, what it is going to do is going to split the incoming traffic, which is a load, is going to split the incoming traffic, which is a load, and is going to allocate to the server. Is going to allocate to the server, which has been assigned by the ASG, which has been assigned by the auto scaling group. The ASG is nothing but it is an auto scaling group. Today we are not going to see about this auto scaling group. So as of now, we are going to see the elastic load balancer. This elastic load balancer is mainly it is used to allocate the server, allocate the incoming traffic to the particular server, which has been assigned which has been assigned by the auto scaling group, which has been assigned by the auto scaling group. Okay. So what will happen? I'll let you know. I'll go for paint. See, this is the user. Consider he is the user. Consider he is the user. So he is going to, this is my application. Maybe it is your application, Facebook.com. It is your Facebook.com or any Google.com. See, the application which we are hitting, the Google.com, Facebook.com, Amazon.in, Instagram.com, WhatsApp.com, it is not the application. It is the IP address of the load balancer. It is the IP address of the load balancer. Till these days, we were using any sites. Go to Google Chrome. If I type Amazon, there is an Amazon.in. It is not an application URL. It is not an application URL. It is an IP address. Internally, it is an IP address. Maybe you see here. I'm just going to ask Google what is the IP address of Facebook. What is the IP address of Facebook? See here, it is giving me some IP address. So it is giving me some IP address. So then I'll copy this IP address and click this address. Here, it is the facebook.com IP address. Just giving proceed. See here, it is loading Facebook.com. It is loading Facebook.com. Now, this time I haven't entered the Facebook.com. I have just used the IP address of Facebook.com. I have just used the IP address of the Facebook.com, not the name, not the name. This name is only for the understanding purpose. I cannot if they give the IP address to all the customers, we cannot remember the IP address for each and every site, right? So if someone asks you log into the Facebook, you cannot remember what is the IP address. So IP address should be 157.240.22.35. I cannot remember this IP address. Maybe one IP address I can remember. There are n number of sites we are daily using. I cannot remember the IP address for each and every site, right? That's the reason they are giving one meaningful URL. That's the reason they are giving some meaningful name. Amazon.it, Facebook.com, Insta.com, WhatsApp.com. It's just a name. Inside this, there is an IP address. We are hitting the IP address internally. Without knowing, we are just hitting the IP address of the load balancer. It is not the IP address of the application. It is not the directly, you are not hitting the application. What you are doing here, it is the load balancer. Is the elastic load balancer. We are hitting the IP address of the load balancer. We are not hitting directly the google.com. We are not hitting directly the google.com. We are hitting the IP address of elastic load balancer. Okay. Once the elastic load balancer has been hit, it will search for the, for example, let's take, we have two servers. We have two servers. It will be under the auto scaling group. So this is your auto scaling group. It is your ASG, auto scaling group. Okay. Now these two servers is capable of handling 100 customers. These two servers is capable of handling 100 customers. Okay. 100 customers is constantly we are getting the 100 customers. So what this load balancer will do, it will allocate the incoming traffic to both the servers. It will allocate the incoming to both the servers equally. It will continue. It will continuously check the health of the servers. This elastic load balancer will continuously check the health of the servers. Like how is the CPU utilization, or is there any issue in the server, whether there is like server is up or whether the server is down. So this load balancer will continuously check the health of the servers. Whether it is working fine, how is the CPU usage, how is the RAM usage, whether it is getting more traffic or whether it is getting more heat. So continuously it will check. The load balancer will continuously monitor the health check of the servers available. Based upon that, it will split the incoming traffic. Okay. Now, suddenly from 100 customers, it has been increased to 1000 customers per second. Suddenly from 100, it has been increased to 1000 customers. So first day, you would have seen what is scalability. Scalability is nothing but If there is 100 to 1000 customers, it will automatically allocate the service. If again 1000 to 100 customers, it will automatically deallocate the service. We would have seen horizontal scaling and vertical scaling. Horizontal scaling is nothing but increasing the number of machines or number of servers. But vertical scaling is not nothing but you are upgrading the same machine. You are upgrading the same machine. Here, auto scaling group is following the horizontal scaling. Is follows the horizontal scaling. What is happening? Whenever there is an increase in the incoming traffic, this auto scaling group will automatically allocate the servers. Auto scaling group will allocate the servers, which means increase the number of servers. It is not going to allocate the incoming traffic. It is going to increase the number of servers. But ELB only, it is going to allocate the incoming traffic to the other two servers as well. It is going to allocate the servers or allocate the incoming traffic to the servers as well. See, ELB is responsible for allocating the servers. ELB is responsible for allocating the incoming traffic to the servers. AST only going to increase the number of servers. Is going to increase the number of servers. Is going to increase the number of servers. See, we are going for one function. Actually, we are going for one function. Example, we are going for one function. In that function, if there are like more people unexpectedly, if there are more people comes into this function, obviously we add only 100 chairs. Suddenly 200 people comes to that function. What that AST will do, it will increase the number of chairs. It will increase the number of chairs in that function. But there is one more guy who is going to allocate. See, you and all go and sit front. Like after filling the front row, come back to the last row and sit. So go, you just go to the left side, you just go to the right side, you just sit here, you just go there. So there is one guy in order to organize those people, whoever is coming. There is one guy who is going to organize the people, whoever is coming to the function, and make sure everyone is getting the chairs. Make sure everyone is getting the chairs in order to sit. So that work is done by the ELB. But increasing the number of chairs is done by the AST. But AST is not going to allocate the servers. It is just going to buy the new chairs. He is not going to allocate the people in order to sit in chairs and all. That work is done by the ELB. He is going to allocate the servers. He is going to allocate the servers to the people. He is going to allocate the chairs to the people whoever is coming into that machine. But AST will increase the number of servers. AST will increase the number of chairs based upon the incoming traffic, based upon the incoming people to that function. AST is automatically increasing. If again 300 people comes in, AST will increase the number of chairs. But this elastic load balance only is going to split it equally. See, first, like here he is going to split. For example, 200 people go to this server, 200 people go to the server, remaining 200 this server, remaining 200 this server. Again, if the server is free, again the remaining people go to the server. Again, repeatedly, it will continuously check the health check of the servers, which is available in the auto scaling group, and it will allocate the incoming traffic to the servers. It will allocate the incoming traffic to the servers, whichever is free on that time. Then only finally we can hit the google.com. So internally everything is happening. Everything is happening like this. Internally, we are not hitting directly the google.com. We are not hitting directly the Facebook, Insta, WhatsApp, or any site. We are not hitting directly. We are hitting the IP address of the load balancer. That load balancer is going to split the incoming traffic and allocate to the servers, which is assigned by the auto scaling group. Finally, we are going to hit the google.com. Let's quickly see how to create a load balancer. So I'll log into this AWS. I'll search for, first I will create an EC2. what I'm going to do, I'm going to create some servers. What is the task is? Task is all about, I'm going to create these servers. Servers, it is nothing but it is an EC2, and I'm going to allow the incoming traffic to the ELB, incoming traffic to the servers. I'm going to create two EC2 machine. In order to show how it is splitting, I'm going to create two EC2 machine, and I'm going to install some Apache server in order to check whether it is working or not. So I'm just going to create two EC2 with the user data, Apache server user data. So I'll go for EC2. All these instances. So click on launch the instance. Yeah, just name it as my Linux machine. Going to select the previous version. And instance type I'm not going to touch, and proceed without a keypad. Let it allow the SS traffic. Go to your advanced details. Maybe here there is a user data. I need to install the Apache server. The user data for installing Apache server. Go to this GitHub. I'll just copy this. So this and all is a dummy. Whenever the hash key is included, that is only for the comment purpose. It is the dummy. Here sudo su. We will be normally commenting this sudo su in order to change as an admin user. So in order to get the admin privileges, there is sudo su, and we are checking whether there is any update. I'm just installing the Apache server. Once the Apache server is installed, we need to start the server. Once it has been started, we need to enable the server. You would have already seen this in the first 2 day session itself. You would have already seen this. So I will again explain. Update Y, it will check for any updates on your machine. It will check for any updates on your machine. If you want to install the Apache server, there is one command yum install -y denotes yes, and HTTP is the name of your Apache server. Forget about this. It is just the system architecture. So once you install the Apache, you need to start the Apache service. So systemctl start apache.service. Once it has started, you need to enable the service as well. So systemctl, system control. CTL is nothing but system control, where if you want to perform start, stop, enable, disable, delete, or like these kind of activities, you need to go for system control. So system control enable service. Once, in order to show me whether it has been successfully installed, I am asking to print hello world from which IP address you are from which host name is nothing but the IP address. The two machines IP address I'm going to create, right? That maybe you can change hello world. If you don't want hello world, just you can change success. Just you can change success. So success from this IP address. Okay. Okay. Then I will click on 2. So I need 2 machines. I'm going to click on launch the instances. So I'll just name it as Linux machine 1. Can't save. I'll just name it as Linux machine 2. Just clicking on save. So there are 2 machines. One is Linux machine 1, and another one is Linux machine 2. Okay, there are 2 machines now. So we need to make sure this we are allowing the SSH we have allowed. We need to make sure whether we have allowed the HTTP as well. So go to the security groups. and only SSH is allowed. You can't edit the inbound rules. Add rule in order to check whether HTTP and gone anywhere. Click on systems. Okay. Now we have allowed the HTTP as well. Now click on your EC2, put your EC2 dashboard, click on instances. So first we can make sure whether the Apache server has been installed or not. If you are clicking this, we'll be getting this public IP address. Go and click here. Okay, we are getting on success message. Success from the IP address 67. Success from the IP address 67. If you want to make sure it has been successfully installed in Linux machine 2, we open copy this. Okay, it is also installing from 225 also, it has been successfully installed. So we have successfully installed Apache server on both the machines. We have successfully installed the Apache server on both the machines. Now I need to create the elastic load balancer. I need to create the elastic load balancer. Go to ELB, search for load balancer. So click on this load balancer. Okay. So click on this load balancer. So click on create a load balancer. See, in load balancer, we have different types. One is application load balancer. This application load balancer. And one more thing is network load balancer. Network load balancer. And third one is gateway load balancer. Third one is gateway load balancer. And earlierly, this gateway load balancer has been introduced recently only. Earlierly, we had one classic load balancer. It is the classic load balancer we had earlier. What is application and what is network and what is gateway? We are not going to see in depth, but I'll give some simple example. Application load balancer will allow the protocol HTTP, HTTPS, whereas network protocol will be allowing the TCP protocol like TLS protocol or the UDP protocol and all. This network load balancer will be accessing. This network load balancer will be accessing. So, but this classic load balancer will support everything HTTP, HTTPS, TCP, everything it will support. Everything it will support. So it was earlierly we were having this classic load balancer. Now also we are having, but no one are using this. See here, if you want, you can use this classic load balancer. It is a previous generation, but no one are using this classic load balancer. So one more difference I can even say, if you are accessing an application, directly through the public network, maybe we can configure it application load balancer. If you are accessing any website, facebook.com, I am just accessing through the public network, my network, maybe my broadband or my like network from mobile, I'm going to access. In this case, see here, this is a user using HTTP or HTTPS. So any site, if you are hitting, it might be HTTPS only. It will be HTTPS only. See here, HTTPS Amazon.com, HTTPS chat, HTTPS WhatsApp. So everything it is HTTPS. So if you are accessing directly through the public network, that is application load balancer. If you are accessing internally, or if you are accessing the backend, if you are accessing the database, if you are accessing the backend DB from your application, not from the public internet, public access. From your application internally, if you want to communicate, see here, from your application internally, if you want to communicate, for example, I am logging into HDFC Bank. So that is the application load balancer. So I'll show here. Here, just move this. So this is my HDFC Bank, and this is my HDFC Bank database. This is my HDFC Bank database. So this is the user. I'm going to directly hit the HDFC app. So from the public network, I'm going to hit the HDFC application. So here we will be using the ALP. Here we will be using the application load balancer. But whenever you are requesting to see the balance, or if you are doing some transaction, this app will internally connect with the database. Because your balance, everything will be available in the database only. It needs to fetch from the database and it needs to show you. It needs to fetch the balance from the database and it needs to be displayed in the screen. So internally, they will use the network load balancer for communicating with the backend systems. Internally, they will use the network load balancer in order to communicate with the backend system. So whenever if you are trying to access one application directly from the public internet, make sure you are allowing the ALB. If you want to internally communicate, you are allowing the network load balancer. Okay. So what I will do, I will click on application load balancer. So click on create. So click on create. Give your load balancer name, maybe demo. Okay. Demo load balancer. I just give the name as demo load balancer. It is asking you are using for the internet facing. Yes, I am going to access directly the internet. So click on internet. If you are going for the internal purpose, it is not recommended. You need to choose the network load balancer. So I'm just choosing the network internet facing and the IP address. I'm not going to change anything. It has been defaultly selected one VPC. So it is asking to map with your any like which means the availability zones. So I will make sure in which availability zone our EC2 instance has been created. Go to your instances. It has been created in 1A. So click on 1A. Click on 1A. And you can also select one more region as one more availability zones as well, because it will prompt to select at least 2 availability zones. One availability zones where your instance has been created. Maybe if your instance is 1A, 1B, and 1C also, you can select all the availability zones. You can select all the availability zones. Then default security group has been created. Default security group has been allowed here. So here I need to select one. Go to create a security group. If we default, let's scroll down. Go to your instance. So go here, and there will be a security group which has been created while here. Copy the security group. So if you are creating both the instance at the same time, both the security group will be same for both the instance. See here, it is ending in E4. Then I'll check this. For this security group also, it will end in E4. If you create separately, again one more security group would have been created. So while creating instance as a 2, 3 at the same time, there will be one security group will be assigned to all the instances. If you are creating separate EC2, then there will be a separate security groups. Just copy this security group, go here, go here. So in this security group, paste it over. This paste it over here. Okay. So I have allowed the security group and okay, click on. So click on create a load balance. Okay. Here, see here, it is asking to select one target group. Then what is target group? Here, it is asking me to select the target group. There is one term called target. There is one term called target groups. Target is nothing but it is single server which you want to connect, which you want to allocate. Target group is nothing but the collection of servers. One or more EC2 machines, it is called target groups. One or more EC2 servers, it is called as target groups. It is called as target groups. So I need to select the target. I haven't created any target group. How can I make this instance to display in this target group? How can I make this two EC2 servers to display in this target group? Then only I can make a connection with the elastic load balancer. Then only I can make a connection with the elastic load balancer. So where is this? See here. So we need to connect the load balancer with this servers. So that you need to create some target group. For that, you need to create some target group. If you go to the instance page, scroll down, see here, under load balancing, we have created the load balancer. It is asking for the target group. See here, below there is a target group. Open in a new tab. So here, click on create a target. See, this target group is not only supporting the servers, which is EC2. It will support the instances. It will support the IP address. As well as it will support the Lambda as well as the application load balancer as well. Lambda functions. You can even integrate this target group with the Lambda, or even you can integrate with the application load balancer as well. So it is not only the collection of servers, it is the collection of IP address, it is the collection of Lambda, it is a collection of application load balancer as well. We are going to see instances because I'm going to attach my instances here. I'm going to attach my EC2 instances here. So I have selected the instance. So maybe give you a target name, maybe demo target. I'll just give it as demo target. Then, so once like you give the demo target, it will ask for the protocol which is to be allowed. So here there are different protocols. So okay, just the thing. Okay, demo target, and make sure you are allowing the TCP protocol, not the HTTP. This protocol is the TCP protocol. This is the TCP protocol. So scroll down. It is also TCP. Make sure TCP is allowed. So click on next. This health check. This is what I said. It is going to continuously check the health of the servers. For that, I need to allow the TCP protocol. And again, click on next. See here, it is showing, hey, there are 2 instances running. Do you want to include all the 2 instances in your target group? There are 2 instances available in your machine. So it is showing there are 2 instances available in your machine. It is showing all the 2 instances here. Okay. So it is asking whether you guys need all the 2 instances to be included in the target group, or only one instance. So I'm going to say just allow all the two instances. Just allow all the two instances. If I have three machines, all the three machines will be shown here. If you want to include all the three instances, just select all. Or if you want to include only two servers, just it is up to you. It is based upon the requirement. So now I will allow all this as a include as a pending below. Now if you see both the instances added to the target group. Now if you see both the instances added to the target group, now I'll click on create a target. See here, now the target group has been created. Target group has been created. If you go here and if you refresh here, just see here, refresh. We need to start because of this STT. One minute, I'll create one more target group. Maybe the fourth time. Target groups are somewhere. So I'll delete this target. Go to create a target group. I'll select the instance. Remote target group. So here let it be HTTP as well. So, but the health check. Okay, just HTTP. That's been displayed here. So rest of the thing I'm not going to change. So there is a create load balancer. So your load balancer has been created. So click on this load balancer. It is going to give one DNS name URL. It's going to give one DNS name URL. If we click on this DNS name, go and paste it in the browser. Or whether HTTP has been allowed. Here, so I just allow the three protocols in the EC2. The one is you need to allow SSH, one is HTTP. Also, you need to allow the TCP protocol. Also, you need to allow the TCP protocol. What I have done is first I have created two EC2 instances. First, I have created two EC2 instances. So in that two EC2 instance, I have also created on load balancer. I have also created the load balancer for the two EC2 instance. While creating a load balancer, it will ask you for the target group. Target group is nothing but it is a collection of servers. So you need to go and create the target group. You need to go and create the target group, and you need to add all the instances available. Make sure, like if there are any three instances, if you want all the three instances added to your load balancer, we need to add all the three instances available, and then you can add it, and then you can attach with your load balancer. Make sure you are allowing all the three protocols in your security group. In your EC2 security group, you need to allow this all three protocols. See here, this time it is giving the request from 225 instance, which is 225. My 225 is the IP address to Linux machine 2. Again, if I refresh this time I'm getting the load from 67, which is 67, my Linux machine 1. My Linux machine 1. Again, if I refresh, it will go to Linux machine 2. Again, if I refresh, it will again come to 61. See here, it is continuously allocating the incoming traffic to the other servers available. Wrong. It will continuously allocate the servers to the, or people continuously allocate the incoming traffic to the different servers available. So if I refresh this, first time it is 2225, second time it is 67, next time it is 225, next time it is 67. So based upon the load, it will allocate the incoming traffic. Based upon the load, it will allocate the incoming traffic to the different servers. It will allocate the incoming traffic to the different servers. As of now, I have two servers. As of now, I have two servers. If I have three machines, now all the three machines would have been equally allocated. All three IP addresses would have been allocated here. Or if you have four machines, elastic load balancer will split the incoming traffic to all the four machines parallelly. You will split the incoming traffic to all the four machines available. So maybe what I will do, I'll create one more instances. Maybe what I will do, I'll just terminate all these instances quickly. So we'll terminate. Clicking on terminate, I will also delete the load balancers. On here, go to actions, go delete load balancer, then on platform. Go to target groups. Actions, delete, just delete. So what I will do, I'll quickly create three more instances. This time I'll create three more instances. Maybe the next machine. Go to your advanced details. So you need to paste the user data. Where is the user data? This is the user data. I'll just copy this and paste it over here. I'll quickly create 4 instances now. I'll quickly create 4 instances now. So click on the last instance. So I'll go to the target group, load balancers, go to the load balancer, and open the target group, open the target group. So before creating load balancer itself, I'll create a target group. So you want the instances. So click on any name. Maybe I'll just give a demo target. Make sure HTTP is allowed and HTTP is for the protocol. Click on next. It is showing all the 4 instances. I need all the 4 instances to be included in this target group. So below it will be included. So click on target group created. Okay. Now go and create the load balancer. Click on create a load balancer. I'll be choosing the application load balancer. Maybe I'll just name the demo load balancer. And it is internet facing IP address. Select any two these two 1 or 2 availability zones. If you want, you can select all the availability zones. And security group, you need to allow the security group while we create an EC2 instance. So go to your instance. Obviously, if you are creating at the same time, for all the 4 instances, there will be 1 security group only. So copy the security group, go here and paste it over here. So launch user and just delete the default. Rest of the thing, go here, select the target which you have created, demo target, and click on create a load balancer. So now your load balancer has been created. Now your load balancer has been created. We need to allow the TCP protocol as well. We need to allow the TCP, HTTP and all. So go to add route, go here, custom TCP it might be allowed. So click on anywhere, then click on add route, allow the HTTP, also anywhere. So click on save routes. Click on save routes. Now I'll go to the load balancer, copy this DNS name and paste it over here. Here. So first time it is showing the IP address 96. Second time 211. Third time 25. Fourth time 96 again. 214. So equally it is splitting the incoming traffic to all the servers, all the 4 servers. See here 96, 214, 211, 25. So all 4 servers has been equally splitted here. All the 4 servers has been equally splitted. So this elastic load balancer is splitting the incoming traffic to all the 4 services based upon the health check, I'll show on demo as well. Go here, EC2. You said health check, right? What is that health check? Maybe I will stop one server. This server, this is my IP address. Which IP address? It is 25 IP address. I'm going to maybe stop. I'm not going to terminate. I will just stop this server. I'll just stop this server. Now, it is now from 96, 214, 211, 211, 96, 214, 211, 96, maybe 211, 96. So 25 is not been allocated because that server is currently down. So this elastic load balancer will continuously check the health check whether it's up or down. So if it is down, it won't allocate the incoming traffic to that particular server. See, 25 is not been allocated because that server I have stopped it. So this is how the user will be hitting the elastic load balancer endpoint. Using this elastic load balancer endpoint, we will be hitting the auto scaling group. Under the auto scaling group only, we are having the collection of servers. Under the auto scaling group only, we are having the collection of servers. So tomorrow we will see how to configure the ASG auto scaling group as well. Guys, if you have any doubts, let me know in today's session, or else let's start.
When we got there is a topic.
So actually, now as a demo purpose, we cannot show the traffic and all, incoming traffic and all. So we cannot give a load and all, right? So obviously we cannot show the demo, but it will be automatically allocated like this. So if first time if I hit 214, right, it means that in 214 there is already someone allocated. Already some people are incoming traffic allocated. That is the reason it is switching to the next IP address. Okay. Tomorrow, I don't want to create the EC2 and all. Tomorrow, whenever you said, right, like auto scaling group automatically will allocate the server, automatically will increase the number of machines. Tomorrow, I'm not going to create the EC2 and all. Auto scaling group is going to create the EC2 instance. I'm not going to create the EC2 instance. That's what's the tomorrow demo. We'll show the demo tomorrow. Let's connect tomorrow.
Okay.